The number of on-road vehicles has considerably increased in the past decade, and represents a major source of air pollution. Besides the gas pollutants, vehicles also emit particulate matter, solid particles with a size ranging from hundreds to several nanometers. Measuring the PM emission is not an easy task, especially for ultrafine particles. The goal of the PEMS4Nano project is to develop a robust and reliable measuring procedure for particles down to 10 nanometers, in particular in real driving conditions. To achieve this goal, emitted particles should be first characterized. Structural characterization of particulate matter is carried out by the FLAM and UMIT laboratory of University of Lille. By the means of transmission electron microscopy or TEM, an analytical technique in which a beam of electrons is transmitted through a specimen to form an image. The image is then magnified and focused onto an imaging device, such as a fluorescent screen, or a camera. A copper grid is used to hold the specimen. In this case, combustion-generated particles produced by an internal combustion engine. After the sampling, the copper grid is carefully placed and fixed in the sample holder. The holder is then inserted in the TEM instrument. A TEM instrument is capable of imaging nanoscale specimens, capturing even fine details in their structure. Ultrafine combustion-generated particles can be observed here. Each one represents an aggregate of several primary particles, of only a few tens of nanometers in diameter. An interesting use case of TEM is 3D tomography. The shape of the analyzed particle can be reconstructed from a series of images taken for different tilt angles of the sample holder. This results in a big collection of images of the same particle. The information about the shape of the particle is extracted from the image series. The data is then interpolated and extrapolated to create a 3D model of the particle.